About 4.5 billion years ago, when the Sun was quite young, around it was a protoplanetary disk. Such disks can be observed around newly formed stars. And the particles that made up the disk bundled up in certain spots over some time. And as those chunks grew more and more, that eventually led to the formation of planets. One of them is Jupiter. Around Jupiter, matter was also accumulating in certain spots, which led to the formation of its large spherical moons, Io, Europa, Ganymede, and Callisto. Because Europa has a non-retrograde orbit and is going around Jupiter's equatorial plane, just like the rest of Jupiter's spherical moons, those factors intertwined together nearly certainly suggest that all of spherical moons of Jupiter, including Europa, originated around Jupiter. That all most likely happened around 4.5 billion years ago, because whenever non-geologically active objects are dated through various methods, nearly all of them show that they are 4.5 billion years old, strongly suggesting that pretty much nearly all objects in the solar system also formed about 4.5 billion years ago. So Europa is 4.5 billion years old. After accumulating all of the same total material that it has now, it got the diameter of 3,100 kilometers. So it is by about 350 kilometers smaller in diameter than the Moon, and its surface gravity is similar to the one on the Moon. It's possible that Europa, almost as soon as it formed, also got its vast subsurface ocean, because of the heating that it retained from the chunks of matter colliding when Europa was forming. So, as it was forming, because of heating, water separated from the rock content, and rock sank below the water as rock is more dense. Then, from the retained heat, the subsurface ocean formed quickly. And the reason that the water ice crust of Europa is not collapsing into the water ocean is because liquid water is more dense than water ice, causing the water ice crust of Europa to float on top of the more dense liquid water. Since Europa has a density of 3 grams per centimeters cubic, that means that it is primarily composed of rock. Although its surface is entirely ice, the subwater layer that formed is nearly purely rock, and is much larger compared to the top water layer that surfaced because of heating. And the core of Europa is likely metallic. Now, another scenario could be simply that Europa formed relatively slowly, and it didn't get enough initial heat to separate water and rock into layers. So at some point after Europa formed, it possibly looked a lot different. Its surface might not have been icy like it is now, but rather mostly rock, combined with some water ice. If that is true, then in appearance it had a look closer to that of the Moon, just without craters. So then if that is true, it was not very reflective and slightly grayish. Still, over some period of time, as the powerful tidal forces of Jupiter and other moons of Jupiter acted upon Europa, that would have certainly created enough friction within Europa, which created the heat that separated the water from rock. And ultimately, as the water came out to the top, the reflective water ice crust formed, and underneath it formed an ocean many tens of kilometers long. However, Europa could have been positioned differently around Jupiter back then, which could have caused a greater or a lower amount of tidal forces acting upon it. Because of that, it could have caused a varying amount of heat within Europa, and therefore an ocean that is differently sized compared to how it is now. So it might have been either larger or smaller than the current estimate of it being around 100 kilometers deep. That all also means that if, for some reason, the geological activity of Europa was much lower than it currently is, then maybe some 300 million years after it formed, it could have had a greater amount of craters than it does now. Back then, there also likely wasn't the brownish color that can be detected on parts of its surface currently. So soon after it got its liquid water ocean and water ice crust, it was like a reflective ball. Its surface temperature, because of its immense reflectivity and the sun's lower luminosity, was likely closer to about minus 190 to minus 200 degrees Celsius, compared to the current minus 160 degrees Celsius on the day side. Now, life on Earth started existing relatively shortly after the Earth formed, the oldest evidence of it dating back to around 4 to 3.5 billion years ago. So because Earth started having life forms that quickly, it's also then possible that Europa, 1 billion years after it formed, when it quite likely had a vast ocean, also developed some sort of organisms. If that happened, then considering the similar conditions, they possibly resembled the ones on Earth, something like a simple, single-celled organism that is also most likely carbon-based. Yes, there is evidence of Europa also having carbon-based molecules. Carbon is essentially the best atom as a basis for life forms because of its stability and ability to bond with 4 other atoms. It is a basis for very complex molecular structures, and it especially goes well with liquid water for life forms. We and everything else alive on Earth is carbon-based. Now, assuming that the orbit of Europa back then is similar to the one that it has currently, then it's quite possible that there were even some hydrothermal vents back then that release heat into the oceans of Europa. Such things are also present on Earth, and they're densely packed with not only single-celled, but also complex multicellular organisms. Looking at Io, seeing that it has volcanoes and is massively geologically active due to tidal forces, then seeing that Europa has a similar density to Io, is similar in size, but has a somewhat weaker tidal force acting upon it, that really only leads to the conclusion that Europa also currently has and has had likely in the past at least some volcanoes that are just under the sea of Europa. And that is the reason that hydrothermal vents also likely exist on Europa. The hot water of hydrothermal vents is caused by undersea volcanoes, just like on the geologically active Earth, where the hydrothermal vents pop up because of volcanoes. And considering that that is a very good energy source, that is also another big indication that Europa has some life forms. By about 2.5 billion years after it formed, so about midway between its formation and now, we can expect for Europa to look similar to how it looks like right now overall, assuming that its orbit stabilized a while ago, which is plausible. So then there were also likely these chaotic regions created when either warm ice chunks or water swelled up to the surface. The cracks 20 kilometers wide and in some cases 1,000 kilometers long, and so on. Its brownish-reddish spots also were likely present back then, but were likely not as pronounced as they are today. They were more dull. The plausible explanation for how these colored spots form on Europa is because Europa has plumes. It was observed that it shoots out water vapor, which is also an indication of a subsurface ocean. The water vapor on Europa was observed to go up to many tens of kilometers up in the sky, in some cases hundreds. When that happens, they can then, with that water, carry organic molecules. And with the water with organic molecules eventually settles onto the surface, then when the sunlight hits that surface, the organic molecules turn into compounds called tholins, which is essentially organic molecules that turn red under some light. Reddish-brownish coloration usually indicates the presence of organic molecules. But because these molecules sort of need to build up over time, and because the sun was less luminous back then, we can expect that the brownish-reddish spots were not as pronounced as they are right now on Europa. Fast forward to how Europa is currently, and it has a surface area that is certainly the smoothest known one in the solar system, but in such a way that its elevation doesn't go up and down much. Some of the tallest mountains on Europa are only about 500 meters tall, so Mount Everest, tallest mountain on Earth, is about 18 times taller. This is a consequence of intense geological activity and a subsurface liquid layer. Although the surface is quite rugged, with all of those cracks, it pretty much erases any craters that it gets and creates a low variation in elevation overall. Considering that its surface area is currently about, at the oldest, 180 million years old, then even saying that the ocean started existing 500 million years after it formed, and saying that it achieved its current orbit 1 billion years into its existence, then that means that its entire surface renewed entirely about 19 times. This is a consequence of having a subsurface ocean and orbiting Jupiter at a distance that is similar to the one of Earth to the Moon. Yet Jupiter is 26,000 times more massive than the Moon, which causes a tidal force on Europa 1,000 times greater than the tidal force of the Moon on Earth. So during the 4.5 billion years of Europa's existence, there was plenty of time for it to have had a massive impact at some point in the past. Maybe even some that were powerful enough to entirely wreck the surface, which could have also caused the subsurface water to also briefly reach the surface a bit and afterwards evaporate. If that did happen, we can't really know currently, since Europa, because of intense geological activity, is simply erasing any such apparent traces of that happening. Currently, based on the strength of Europa's induced magnetic field, the estimates are that the ocean of Europa is likely within a range of being 60 to 150 kilometers deep, meaning that it very likely has at least the same amount of liquid water as the entire Earth, or double, or maybe even triple. So by this point, if life started existing early on in Europa, unless it died out for some reason, it very likely evolved into something else, just maybe something even that is quite complex, akin to a multicellular organism. Right now, Europa is also very likely redder than ever before, because of an accumulation of fallens on its surface, and because of an increase in luminosity from the Sun, which reacts with organic molecules even more now. Eventually, after a few billion years, as the Sun's luminosity will be increasing, the temperature on the surface of Europa will reach points of about minus 20 degrees Celsius, on average during the dayside, which will still be enough to support an icy crust and a liquid ocean. However, the water-ice crust won't be as hard anymore because of the much higher temperature. The higher the temperature, the less hard is ice. That means that the surface will either be more easily cracked, or, since it will also be less hard, it will also be less brittle. So such a temperature might even lower the amount of cracks that it has currently, since it would be more flexible and malleable. Whatever the case is, it will certainly look a lot different from how it looks like right now. Now, we can expect that this far into its future, its reddish-brownish coloration will be even more pronounced than it is right now, significantly more. And the increased temperature on its surface will also increase the rate of sublimation of water ice, possibly leading to a creation of an atmosphere that is even slightly visible. So that atmosphere, if it gets to exist, will certainly most likely be water vapor, since that is what will be sublimating. But it will also have some oxygen likely. Europa also currently has a tiny bit of gas oxygen on its surface that is created when solar radiation breaks down water on its surface, which then releases oxygen. Then, as we move forward into the future, as billions of years pass, Europa will start approaching that 0 degrees Celsius and beyond. And because of that, there are really two scenarios, based on how quickly that happens. If the change in temperature on Europa is quite slow, then slowly over time the water will simply evaporate off of its surface and escape into space due to high molecule velocity and low gravity of Europa, eventually leaving the bare rocky layer exposed. But if the change in temperature is rapid enough on Europa, then maybe it could actually build the atmosphere quickly enough before it escapes, such that it is within a bar or few bars of pressure. That would then lead to water ice melting and leaving the ocean exposed. So a few billions of years into the future, Europa might have an ocean on its surface and a thick cloudy atmosphere with some oxygen. From space, if the atmosphere of Europa is mostly water vapor, then Europa will look quite white. It will be a cloud atmosphere essentially. Eventually the Sun will enter the red giant phase, and by that point and afterwards, the future of Europa is pretty certain. We know that the Sun will enter the red giant stage from observing other stars and seeing that they are pretty much all composed mostly of the same thing, which is hydrogen and helium at different proportions depending on time. So because laws of physics act in a linear, predictable fashion over time on essentially the same thing, which is a ball of hydrogen and helium, we then know that if a star of a similar mass to the Sun is a red giant, then it is about 10 to 12 billion years old. So about 5 to 7 billion years from now, the Sun will also enter the red giant phase, achieving a diameter that is about 300 million kilometers, essentially reaching the current orbit of Earth with its size. Assuming the Sun loses about 20% of its mass by that point because of increased fusion during the red giant phase, Jupiter, and therefore Europa, will then shift to be about 1 billion kilometers away from the Sun compared to the current 780 million kilometers away from the Sun. The 20% lower mass from the Sun will make the Sun have a weaker gravity and cause that shift. For comparison, the Earth is 150 million kilometers away from the Sun currently. But even with that orbital shift, Europa will be receiving about 1,800 times more sunlight than it currently does, which is 70 times more sunlight than the Earth is currently receiving from the Sun. So no matter how you spin it, Europa will almost certainly be reaching very high temperatures on its surface, enough to vaporize its entire water layer, which will certainly leave only the rocky core left at that point. That will also increase the average density of Europa by a bit, because most of Europa will then be rock, and the rock is denser than ice, and it will also get a slightly smaller diameter. From Europa, the Sun will appear to be about 34 times larger in the sky than the Sun is currently from Earth. Europa also likely won't have an atmosphere of some water vapor at that point, because such high temperatures will make any gas in its atmosphere have very high velocity, enough such that it will entirely escape eventually from Europa's weak surface gravity. If life forms existed up to that point on Europa, then moving forward they certainly will be dead. Eventually, relatively shortly into the red giant phase, the Sun will reach a critical point of fusion in its life cycle. About 8 to 10 billion years from now, it will shed its outer layer, creating a nebula and leaving behind only the dense core about the size of the Earth, that is still about 200,000 times more massive than the Earth, and it will be releasing stored energy, so it won't have fusion anymore. That core is the white dwarf Sun, and this phase of the Sun will last for a few hundreds of billions to possibly up to 1 trillion years from now. So Europa will relatively suddenly go from extremely hot to pretty cold, as it will be receiving a lot less sunlight from the white dwarf Sun. And over the course of following billions of years, the white dwarf Sun will achieve a semi-stable surface temperature of 10,000 Celsius. And by that point it will also have a mass probably approximately around 40% less than its current one. So that will cause for the distance of Jupiter and Europa to shift even further away from the Sun, going from 1 billion kilometers, the distance established during the red giant phase, to up to about 2.3 billion kilometers away from the white dwarf Sun. That is billions of years into the white dwarf phase. So Europa is going to be receiving many millions of times more sunlight during the red giant phase compared to the white dwarf phase of the Sun. This will cause the surface of Europa to be quite dim and colder than ever before. So many tens of billions of years into the future, Europa likely won't have an ocean, since by that point all of the water will be evaporated and escaped. However, that doesn't mean that it will be entirely geologically dead. Unless Europa's orbit shifts to be much further away from Jupiter than it currently is, and of that there are no known indications, then that means that very strong tidal forces will then also be acting that far into the future on Europa, which will cause for it to still have lots of friction, so it will also be generating heat. As already previously mentioned, Europa currently likely has undersea volcanoes, so those volcanoes will then just be more exposed, because the water ice layer will be entirely gone by that point. That means that Europa could be having volcanic eruptions on its rocky surface tens of billions of years into the future, still erasing craters, and quite likely then also creating some really tall mountains that it never got to have before that point. It probably will also never get to have an atmosphere as well though, as its surface temperature because of the white dwarf Sun will be about minus 250 degrees Celsius, which is enough to freeze pretty much any gas immediately that reaches its surface. If the orbit of Europa remains stable for hundreds of billions of years, then it could continue being geologically active as the white dwarf sun is running out of stored energy, and maybe even after the sun runs completely out of stored energy, even after Europa is left in near pitch black darkness.